I mean, if you're asking as an industry rather than an individual, then I think the comic pretty much explains it. We want to just automate stuff and reduce manual work.
Yeah. So topic for today is around software engineers, and I am presenting my thoughts on the existential context, upliftment, and the possibilities or pathways beyond uh, as a software engineer. So, any idea or any thoughts on what our existential context as a software engineer is?
Ishan, sorry, repeat the question. I was concentrating on the cartoon.
Yeah. So, any idea so as to why we do what we do? What is our existential context in terms of like what we are doing, why we do it?
Money.
Yeah, Priti caught it.
Passion.
Yeah, passion maybe, but not the top priority.
Okay.
I mean, if you're asking as an industry rather than an individual, then I think the comic pretty much explains it. We want to just automate stuff and reduce manual work.
Yes, it's about business. Whatever we do as a software engineer, except for being passionate about it and just fiddling with things, it's all about business every time. And there's a famous quote by Tony Soprano: it's just business, nothing personal. So we should keep the business out of our personal boundaries. So first point I would like to make is like we are hired to create business value and not to program, just to program things. I haven't seen any events wherein the keynotes emphasize on underlying programming languages or the infrastructure or the code quality on the product launch. Apple does not showcase their code coverage percentages or what programming languages they use inside or the infrastructure on what their product is running on. Doesn't necessarily mean that we shouldn't do the stuff, but it implies that the number one priority for building any software as a software engineer should be the business value. Even if you own a product or if you have your own company, the number one priority would be to create or generate business value. Without that, it's just something working around and has no meaning. Now, businesses mainly converge on two things. That would be increasing of revenue and reduction of costs. As a software engineer, our function should be either to add revenue or reduce costs. And these should be the only goals which we should be looking forward to. Examples would be, let's say, we take our own product, Roo. It provides like amazing recommendations, but if it doesn't generate enough revenue, then it's of no use. Same is with our other product, Fastnex or Talent 500. It provides amazing recommendations for candidates, but unless you sell the product and someone is willing to pay for it, it is of no use. And comparing these two products with a simple CRUD app with just, let's say, logs timesheets and is not really technically complex, nor it has anything wonderful or let's say AI or any other fancy stuffs built inside it, it still saves a lot of time. Doing the same thing on paper would take a lot of man hours, and validating the same behind it would also add another man hours. And this will incur costs in terms of time and money on the company. Whereas a simple CRUD app facilitates and reduces time and resources like money for gathering the data which we require to run our business. So if your product or your software does not generate business value, it is of no use. But if even if it's not complex enough, or it's not doing wonderful things, if it generates business value, it's something which will be useful, and will be maintained by companies and will be used by the users. Second thing would be the concept of profit centers and cost centers. These two in the purview of business are like poles. Profit centers would comprise of people, resources, or anything that generates revenue. Anything and everything except that constitutes cost centers. And uh, in in an implied sense of cost center, all engineers, which include us, are usually very highly paid cost centers. If you consider IT departments versus the actual business working of business, let's say insurance, the cost that goes away into operations and maintaining the IT infrastructure and the softwares and products which bring in the business is pretty high. And I have worked with one such company. So that cost comes up to 30% of revenue of the total business generation, excluding the operations cost, which is spent on running the business in actual terms. So we are perceived as cost centers, and this particularly sets the optimization antenna of whoever is sitting up the chain, typically MBAs, twitching. This is how the wonderful concept of outsourcing came up, and which will be whose base idea would have been like, let's replace the expensive cost centers who do something good, and we don't really care about whatever they do, and let's just put and reduce our costs and transfer our work to cost centers in a lower wage country. Now, typically, and in terms of economics, nobody ever outsources profit centers into a lesser developed market. So we are cost centers, and our goal should be either to generate enough revenue or reduce more costs which are going to be incurred as a part of our ongoing activities. So the next point which I would like to touch upon is, how do we improve ourselves as a software engineer? First part was around the context wherein we should operate. And the second part will focus on how, as a software engineer, can we grow. Now, one of the most important things is playing for longevity, having a vision. So picking up a new language doesn't take more than a few weeks of effort. But just sticking to a single language and keeping binding yourself to a single technology, framework, library, or a programming language doesn't help much. arming yourself with the general knowledge that you can operate interchangeably with any framework, language, front end, back end, data engineering. You draw your limits, but at least having a knowledge and having an all round picture helps to be a better software engineer in my uh, in my opinion. Now we also should try to be like John Wick. Actually, the growth, what we do in our organizations, technically, financially, whatever we consider, happens just because of taking ownership of the things. Being like John Wick, like having a task assigned or some piece of code or feature assigned to you and taking end-to-end responsibility of the same, whenever whatever is assigned to you gets and improves your technical abilities as well as the business uh, business value which you generate as a software engineer. An example of this would be breaking all silos. Let's say if someone is working on the back end, they should try to at least uh, know how their pipeline is working, how it gets deployed. Plus, in addition to this, whatever uptime your API should give should be your responsibility. And having an overall picture wherein your software connects with other interfacing systems like, let's say, front end, mobile apps, or your data analytics pipelines, or where suggestions come in from and how you render them as a whole system should be your priority. And you should have end-to-end knowledge of everything. Doesn't necessarily mean that you have to work on it. It doesn't really take time to learn things and start working, but having a knowledge of at least your part of code and taking the ownership from writing code till the delivery and beyond is what, in my opinion, constitutes an experience, and wherein experience doesn't correlate to any years of experience or skill in programming. Now, the main topic which I had chosen for today was the beyond, being John Wick. How would you be a John Wick? The topic which I touched upon last has a specific term associated with it, which is site reliability engineer. Site reliability engineering is a discipline and moreover a mindset which was formulated by Google, and the term was itself coined by Google, which spread across the industry after it became more and more usable and it had proven benefits. Now, site reliability engineering is a discipline that incorporates all the aspects of software engineering and then it applies them to infrastructure and operations problems also. Typically, where Google came from and what Google operates on is uh, they have budgets for site reliability engineers per team and per product. They typically do not go above the budget allocated for a site reliability engineer. Where site reliability engineer differs from DevOps is the underlying goals and foundational principles are same, but DevOps is restricted to having communion between operations and IT. That's it. There is no ownership and there is no scalability perspective involved along with the ownership. It does provide software with continuous integration and continuous delivery, but then no one is responsible for what they develop, is somewhat the philosophy of DevOps. So DevOps becomes a subset of site reliability engineering. Site reliability engineering encompasses everything, and it also encompasses DevOps. Now, site reliability engineer, according to Google and according to Ideation, is someone who is a software engineer and is assigned to do operations works. So let's say if you are a backend engineer, um, writing the code, taking the code from your machine, pushing it to your code versioning system, applying CI/CD over it, and then when it is deployed in the server environments, monitoring, ensuring uptime, anything and everything related to your crashes, errors on the server, and ensuring that your whatever code or piece of software or product which is assigned to you is your responsibility, and it maintains uptime. So that is a broad idea of site reliability engineering and how it differs from DevOps. Now, before we dive more into SRE, the underlying principles of site reliability engineering, it is specifically a mindset, not an actual framework or a practice that you go and apply. It comes from within, and it encompasses everything that uh, revolves around generating the business value and ensuring that the business value or business operations are not impacted and your software or your product keeps running no matter what. This encompasses everything: fault tolerance to load balancing to replication, everything. Now, one of the pillars of DevOps, all the pillars of DevOps, they are satisfied by site reliability engineering. But there are minor differences, or maybe let's say some more points added to the pillars of DevOps, which constitute SRE, site reliability engineering. SRE, accepting failure is a norm for DevOps, but SREs embrace risk. So having the major part of setting up a SRE mindset or ideology in an organization is to embrace risk. Anything and everything can crash, can go down, and what matters is how you respond to it and how you prevent it from happening again. SRE quantifies failure and availability in a perspective manner using two important terms: service level indicators and service level objectives. So service level indicators are, let's say, measures of your uptime. Service level objectives are your internal organizational uptime or service level, what you would be providing or what you should be achieving. And there is a third term called service level agreement. Service level agreement is an agreement between the business or the product provider to the customer. If we consider our case of Vroom, it would be providing recommendations at at a uptime of 99.9% is a typical example. But the service SLAs, which constitute big companies and products which are offered by big companies, they are typically in the range of 99.5 times 9, so 99.99999. And achieving this much of uptime and providing an SLA which conforms to this level of uptime is not an easy task. So the culture also should mandate and handle crashes or incidents without having someone to blame for it. We can always have the SRE culture in Google. It is such that um, downtimes and crashes or service being impacted by other service deployments is okay. But whatever happens, and if it's a bigger outage or a smaller outage, doesn't matter. Whatever happens, there's a post-mortem report generated after the incident happens. So, but the first priority would be triaging the incident, bringing the services back to their normal state. And the next priority then becomes a postmortem, which is carefully documented and published on a central repository and shared across the organization so that you can, in a way, handle similar situations at later stages. Uh, Another pillar of DevOps is reduction of organizational silos. So, as I stated earlier, SRE um, the idea of SRE incorporates the ownership of everything inside the product. It does not differentiate between tires or whose code it was. All what matters is your service or your product as one maintains its uptime and serves the targeted customers, keeps your business value up and generates revenue by giving uptime to your product. SREs are in sense developers or software engineers which do the operations work. Now, if you consider the other way around, someone who is a DevOps or a Ops or a sysadmin guy, they would not be getting into too much details of the code. They'll always have some dependency on the software engineers. But the other way around would be a very beneficial case. Even smallest things which require manual intervention, software engineers have the ability to script and automate that to a very higher extent such that no manual intervention is required. Now, as a part of delivering business value, service level agreements are the holy grail of what you offer as a product, and you are held accountable for what you promise in your service level agreement. If you have noticed, or if you know about the recent outage last week, which was there in the Northern Virginia region, I guess, of Amazon, multiple services and products got impacted due to it. But then this cannot be a reason to not to obey or in a sense not what to say, stand up to your service level agreement with your own customers. As far as I remember, Slack is one of the companies which Slack or some other company is one of the companies which offered credit to the customers due to the downtime caused by AWS. Now, AWS infrastructure was not in their control, but as a part of SLA agreement, they honored their agreement and they gave sufficient credits to their customers for to compensate for the downtime which was created due to the outage incident. So in Google, they have a concept, and as an example, they have some high level of uptime, which is promised in their SLAs, which the people generally do not read, but then it is there in the SLAs. Let's say Google has an uptime of 99.99999% for a service. It goes even beyond this at times. Maintaining such a high uptime is very crucial, important, and critical for everyone working at Google. Now, product teams, which constitute of product managers or product owners, they have a mandate to have or honor the service level agreement with the customer. Let's say that if there has been a downtime in a quarter, typically targets are considered per quarter. Uh, let's say if there has been a downtime of few hours or minutes, which brings down your existing service level indicator numbers close enough, let's say 99.4 times 97. At situations like these, what happens at Google is the releases are frozen until your quarter ends. You cannot release your software no matter what. You cannot deliver new or generate new business value for new services which you want to deploy. And all the deployments and further releases are stopped until you cross the quarter. So this is some of the things which are followed at big companies. Even in case of failures which are not of high magnitude, the mean time to resolution is what matters, and as a culture is propagated throughout the teams, and the target for the software engineers is to keep this mean time to resolution as low as possible. Uh, this comes as part of a culture which promotes on-call duties, and it also does not hold a single person liable for any incidents or outages. The next pillar of DevOps would be leveraging tooling and automation. So as I mentioned earlier, any and everything which can be automated or which is boring or a mundane task has to be automated. You can never do the same thing which is boring to you and do away with it. First reason being, humans introduce human errors inside repetitive and mundane tasks. So the best way of going around is automating any and everything that needs to be done and that can be done via scripting or any other form of automation. Maintaining service uptime, you cannot maintain a service uptime until you have all the metrics which should be captured and which you can capture. SRE proposes to measure and store, or let's say log everything which is possible. So when there is an incident or the numbers go down, you have a system which alerts people and gets them onto their laptops to fix the issue. Typical thing at Google scale would be having systems run on different machines or instances or VMs on different clusters and different geographic regions. All the systems, they provide or send their logging into a centralized system in an asynchronous manner. And this system is what is called the brain of their logging or alerting or uptime measuring metrics. Specifically with Google, they have already developed a data exchange format that is based, that is not a plain text format. It is based off, it is a Google thing, and they have their own format for representing the logs and sending it to the server, even errors. And what their servers do is they just consume these messages, and for optimizing this, they have somewhat equivalent of a bit manipulation system. And this bit manipulation and calculations through the bits, it becomes pretty fast as compared to parsing high volumes of textual data. So there is a central server which manages the logs and monitors health of all the and each and every server which is there in their region. Typically, this server also needs something to measure its health. So they have a backup, or well, let's say failover, or a secondary server which monitors the uptime of the primary monitoring server. Everything that constitutes a software system, SRE proposes that it is always a software problem and it is not something vague and cannot happen out of the context. It is not any magic that happens to your systems. It is surely always a software problem. So what SRE says, and what a traditional saying in SRE world is, hope is not a strategy. Anything that happens has a reason, and you should be able to cope up and avoid the situations. And even if they happen next time, you should have enough knowledge and resource and metrics to counter that when it happens again. So having said that, this is a brief overview of site reliability engineering. Now, if anyone has any questions, I would be happy to answer them. This session was pretty short in terms of coverage of content, but fitting everything into a single session for this is almost impossible. So yeah, I'm open to questions now.
I have a question, Ishan.
Yeah.
What do you need to do to become a software engineer now?
You just need to have something that types the code. Rest all is what you have with you.
All right. Can you mentor me along those lines?
Definitely.
Thanks, Ishan.
Yeah. So anyone else has any questions? I think I'd take it as a no. Okay, then. Thank you, guys.